Okay, so now we're going to do example 2. So if we just take a look at the question, it's a slightly more complicated version of example 1. So it says graph the function of f of x. We have minus 2 bracket x plus 1 close bracket squared plus 1 and its inverse. So just slightly more complicated than number 1. And it says determine the equation of the inverse relation as well. So step by step we're going to do it. I've copied the formula and I've labeled the graph. I haven't labeled that many points because I try to leave the graph as uncluttered as possible so it's easy to understand, but if I need more labels I'll add them at a later time. So because we're all chapter 1 experts, now we can look at this and we say, hey, our parent function is y equals x squared, and now I have to think, what were my changes? The first thing I can spot out is the minus 2, and that tells me two things. I have a reflection, I'm going to do short forms, reflection through the x-axis. I have a vertical stretch by a factor of 2. I'm vertically translated by 1, and then I'm horizontally translated by 1 to the left. Remember, because it's on the inside, it's always going to be opposite by 1 to the left. And sorry, my vertical translation here is going to be by 1 up. Forgot to mention that. But now let's go through it. So imagine, I'm not going to draw every single version of our transformation because technically our question is not even asking us to graph our parent function, it's only asking for the inverse. So I want to keep the graph as uncluttered as possible. I'm just going to draw the final version of what the graph will look like. So you have to think, how does my vertex move? When y is equal to x squared, it would just be at 0, 0, and now it is going to be what? Reflected through the x-axis. So now instead of my parabola opening up like it normally would, it's going to open down. It's vertically stretched by a factor of 2, so I'm doubling my step pattern. So instead of from 0, 0, I'd go 1 and 3, then I'm going to go 2 and 6. And the other thing that it does, it moves up by 1 and left by 1. So that I can graph right away. Up by 1, left by 1, this is my new vertex. And now I know it opens down and the step pattern has been doubled. So when I move right 1, instead of going up 1, I'm going to go down 2. And then remember, our axis of symmetry is right along the vertex, so we can mirror that point. And we're just going to do one more point. So I move one more to the right, and then instead of moving 3, I'm going to move 1, 2, 3, 4, 5, 6. So slightly off my grid, but that's okay because I'm going to draw our parabola here so that it's nice and visible even though my point is off the grid. So this doesn't go through that point perfectly, but you get the idea. That's our parent function. Now it's going to be reflected through, remember, y is equal to x, so this diagonal line, and it looks really ugly, right, because visually this cuts right through my parabola, so it's not very easy to see what my final shape is going to look like. But remember, the domain and range on an inverse function is going to be swapped. So what I can do is list my old points before my inverse process and then list the new points. So I'm just going to list these 5. I'm going to do 1, 2, 3, 4, 5. So my first point is going to be at negative, what do I have? 3. And, oh boy, this is going to be very negative. I'm going to label my graph a tiny bit more, even though it's going to make my graph look a little bit more cluttered. It's going to help us. I've got minus 4 here, minus 6 here, and then it'll be at minus 7. So minus 3, minus 7. Then I've got minus 2, minus 1. Then I've got minus 1 and 1. Then I've got 0 and minus 1, because now we've gotten to our mirrored side because we've passed through our axis of symmetry. And now I have positive 1 and negative 7. And now when all my points are transformed, or I shouldn't say transformed, maybe inversed, we're just swapping our x and y values. So minus 3 minus 7 becomes minus 7 minus 3. This becomes minus 1 minus 2. This becomes 1 comma minus 1. this becomes minus 1 comma 0, and this finally becomes minus 7 comma 1. And now we're going to see what that looks like, because I just need to plot my new points and find out what's going on. So again, I have to label this section of the graph. I've got minus 4 here, minus 6, and minus 8. And now I'm going to slap on my new points. So I've got minus 7 and minus 3. I've got minus 1 over here and minus 2. I've got 1 and minus 1. I've got minus 1 and 0. And then finally, I'm going to have minus 7 and 1. So let me just graph this 1 second. I will recenter or realign the page once I'm finished graphing. Apologies if you can't understand my voice super perfectly, because I am sick. That's what our inverse function, or in this case a relation, right, because we can see that it fails the vertical line test right off the bat, but that's what our inverse relation is going to look like. Alright, now what else does the question ask us? It also asks us for the equation of the inverse. So just like we do for linear functions or relations, and just like we did in example 1, we're going to take our formula, which is f of x, but I'm going to write y to simplify swapping our variables. Y is equal to minus 2 x plus 1 to the power of 2 plus 1. And now we rinse and repeat. We do exactly what we did before. Our y becomes an x, and our x becomes a y. And then we just need to re-isolate to get y all by itself. And so, to get rid of this, the plus 1, I just need to subtract 1 from both sides. So I have x minus 1 is equal to minus 2 y plus 1 squared plus 1 minus 1. Get rid of these two because they cancel out. Now I need to get rid of my negative 2. So I'm just going to divide by negative 2 on both sides. So I'm going to have minus x minus 1 over 2 is equal to, these two will cancel out, I just have y plus 1 squared. And, oops, sorry, I'm almost out of frame. Now to get rid of my square, I need to square root both sides, but remember you have to take the positive and negative values. So I'm going to have plus minus the square root of negative x minus 1 over 2 is equal to y plus 1. Now you might be thinking, and I know we're not done yet, but you might be thinking, hey, this isn't allowed. I'm not allowed to have a negative inside the square root. You're right. My final result is not allowed to be negative, but if the result here from my fraction, so x minus 1 divided by 2, ends up being negative, it'll then be multiplied by the minus in front to give me a positive final result underneath my square root. So then I'm still working with real numbers. So we're still okay. And then the final thing we need to get rid of is the plus 1. So I'm just going to write my final answer over here is y is equal to plus minus the square root of minus x minus 1 over 2 minus 1, right? Because we're getting rid of the positive 1 by subtracting it from both sides. So this is our final answer. You can also write negative 1 in front, so negative 1 plus minus the square root of everything here, but the answer would be the same. And the final thing that the question asks us is down here. We already did the first part up here, but down here, is the inverse a function? Can we do anything with f of x to make the inverse of f of x a function? So the answer is yes, we can, right? We can restrict our domain or our range in order to just have the half of our now inverse parabola that would pass the vertical line test. So I can restrict the domain in such a way to have only this half of the function be available. Technically, it's a relation before I restrict it, but in order to make it a function, I would restrict it so I'd only have the top half or the bottom half, because on their own, either one of them is still a function because they pass the vertical line test. Okay? So, let's restrict the domain. Now, try it on your own for a second. I'm gonna give you a chance to pause the video, so I'm just gonna pause here for 5 or 6 seconds, and then we will take it up together. Okay, so first thing we need to do is see at our original function here, we'd have to restrict the original domain to essentially cut our original function in half so that our inverse function is now only the half that passes the vertical line test. So I've got two options. Option number one is that I can restrict the domain of my original function. So the domain of my original function, I'll write it in blue, so that x is still an element of the real numbers, but x has to be what? Less than or equal to -1. Or option 2, this would make it domain is an element of the real numbers, again, where x is greater than or equal to -1. So one of these two options, because when these two become the now restricted domain of my original function, when it turns into my inverse, I'm just going to have my new range be that y is an element of the real numbers, where y has to be less than or equal to -1. And here, if I go with option 2, then I would have y is an element of the real numbers, where y has to be greater than or equal to -1. Oh, sorry, I forgot the minus, but -1 over there. Okay, and we can see how it works. If I restrict my domain here in my original function so that it has to be less than -1, I only have the half of my original function that isn't covered up right now by my ruler, and the resulting inverse will only be this. I'll only get this half right here. That's not being covered up by my ruler. And then the opposite's true here. If I restrict my original to just this, then I would only have the top half of my inverse. Okay? So, and if you have any questions, don't worry, you can always ask me when I am back tomorrow, because hopefully I will be feeling better tomorrow. But the restricted domain for f of x would be, I'm just going to copy the answer here so that you have it for your notes. X is an element of the real numbers, where x is less than or equal to -1. Obviously, the order doesn't matter. You can have a greater than -1 here and then less than here. Doesn't matter. It's both options. Doesn't matter which one goes first. Okay. And that's it for question 2. Alright, so click on to the next video for example 3, and then that'll be our whole lesson.